Alright, so we're going to start off this section by talking about redox reactions. So the overall theme here is types of reactions. These have been kind of introduced, but there's really a lot more to talk about with them. So we're going to start here. Then we will bring in coenzymes, which are used for redox reactions in biological systems. That'll be the next video. Talk about acid-base, and then we'll have one where we just kind of review, because we've talked about some other types of reactions, kind of in the somewhat distant past. And so just to kind of compare, contrast, refresh your memory, we'll have kind of like a summation video at the very end. So it's going to be kind of the plan of attack here. So to start out, redox reactions. So these are any reaction in which the oxidation number of a molecule, atom, or ion changes. So that's like your textbook definition. We're not really going to worry about oxidation number here. It's not really relevant to the level of discussion we're going to have. So redox refers to two types of reactions. So you can change oxidation numbers up, and you can change oxidation numbers down. If you change them up, that's called an oxidation reaction. If you change them down, you're reducing the oxidation number. It's called a reduction reaction. And so the naming system might seem a little bit weird for what I'm about to write, but keep in mind that this is actually a system that was developed before electrons were really known about. So I give an electron definition, but well, we'll talk about it more in a second. So we're going to define oxidation and reduction. And so I've defined them in terms of oxidation number. You know, oxidation number goes up, oxidation number goes down. You know, you oxidize, you reduce. But what does it mean in terms of electrons? Well, it actually goes the other way. So oxidation means you will lose electrons from your reactant. And we are saying oxidation number goes up. So I said that before, let's get it in writing. So reduction, well, if they're opposite of each other, guess what that means? What's the opposite of losing electrons? Gaining electrons. So we gain electrons from a reactant. And that means our oxidation number goes down. Okay, so these are kind of like the real technical definitions. So we're going to really frame it here for just this class. So all I'm going to say to lead in the next part is, you know, this is nice background information. This is like official definitions. But when it really comes down to it, you just have to remember two types of reactions and which way for them is an oxidation, and that the reverse of that is a reduction. And so the first type of redox reaction, we're only going to focus on organic compounds here, is dehydrogenation. So that's the first type of oxidation. So there's two types of oxidation you'll need to know, and two types of reduction. And we've talked about hydrogenation reactions, and so you can probably guess what dehydrogenation is, and you might be able to guess what the reverse of this is. That's going to be a reduction reaction. Alright, so dehydrogenation is, you know, maybe we have a saturated hydrocarbon and we unsaturate it. This isn't balanced, but this is what you would see. If you see all single bonds turn into at least one double bond, that's a type of oxidation. The other type of oxidation is increasing number of carbon-oxygen bonds in a molecule. Alright, so what does that look like? Well, maybe we have something that, looks like this, and then maybe it becomes this, and we can oxidize it again, and maybe it looks something like that. This would be two different oxidation reactions. Boom, boom. So we go from 0 to 1 carbon-oxygen bond. We go from 1 to 2. So this is an oxidation reaction right here, and this is a second oxidation reaction. And we could keep doing that. We could keep going and going and going, just adding more. Generally, you're going to have an alcohol that turns into a ketone or an aldehyde, just depending on where that alcohol is. So this would be a ketone because it was in the middle of the chain. If it was on the end, you get an aldehyde, and then you start bringing in more alcohols. The ends can also turn into carboxyl groups. Basically, you're just looking for carbon-oxygen bonds to go up, and you got yourself a oxidation. And in terms of this type of reaction, it makes a ton of sense, right? Like oxidation. Look, I'm adding oxygens. I'm adding connections to oxygens. That's oxidation. That's not bad. This one's a little trickier. And so generally what you're doing is you're cutting down on your number of like carbon-carbon and carbon-hydrogen bonds. Like we're cutting in here, so there's less hydrogens. Like these aren't balanced. I'm just showing what's happening to one of the reactants as it carries through. This isn't a complete chemical equation. Same deal here. I'm missing 2 hydrogens on my product side. So, keep that in mind. So what is the opposite of this going to look like? What would a reduction reaction look like? Well, I could be really lazy and I could just draw these arrows going the other way, and that would fit down here. But the first type of reduction reaction, what's the opposite of dehydrogenation? Well, it's going to be hydrogenation. And so, maybe you have something like that, and it becomes something like that. So my double bonds become single bonds. And so there's some hydrogen gas or something being involved, something that's carrying hydrogen in this reaction. And in the other situation, well, what's the opposite of increasing number of carbon-oxygen bonds? Decreasing number of carbon-oxygen bonds, alright? I ask some tough questions sometimes, I know. So, what might that look like? Well, maybe we got something like this. This would be a series of, there's a reduction, here's a reduction. So I just put 2 of them in series. But if you just saw this by itself, that's a reduction reaction. If you saw it like this, that's a reduction reaction. And those are all the types I expect you to know. Seriously, that's it. You're looking for anything more than this, you're not looking for a redox reaction. This is what they're going to look like in this class. We're going to add some detail to this in the next video with coenzymes. But yeah, that's pretty much it. So if you see something like this, you go, oh, okay, well, what is that? Oxidation or reduction? What do you think? Well, maybe I tried to razzle and dazzle you by having a double bond in there, but it was at the beginning and the end. But we went from 0 to 1 carbon-oxygen bond. Therefore, this is an oxidation. We increased the number of carbon-oxygen bonds. The double bond was there the whole time. It didn't change. So don't be fooled by something like that. Or if I have something like this, hold on, that doesn't work. This is what happens when you make stuff up on the fly sometimes. There we go. Well, what's that? Well, I've got a dehydrogenation reaction, And so that's going to be another oxidation. Try to distract you with the carboxyl groups, but they don't actually change in the chemical reaction. What changes is right here, just like what changed was here. So you can have all kinds of stuff in there, you know, or you know, what if we go something like that? It's another oxidation. If it goes the other way, it would be a reduction. So I keep showing oxidation reactions, but whatever. I have a bias tonight. Not a big deal. I'm all about the oxidation apparently. But again, we're just looking for that change. There was nothing there. Now there's a carbon-oxygen bond. I guess it was technically there's a hydrogen there. Don't get all offended for the hydrogens. I know they exist just because we don't draw them. All right, so yeah, just know those reactions when you see them. Know it's redox, and then be able to determine is it oxidation or reduction. And I gave you the whole playbook for that. So moving forward, what we're going to do in the next video is we're going to talk about the extra pieces that come in when you handle this in a biological system. And essentially what we're doing is, I didn't show any balanced reactions in this video. We're going to show how nature keeps things balanced. Where do those hydrogens go? Every type of oxidation we did, hydrogens were taken off the molecule, so they had to go somewhere. That's what we're going to show in the next one. Alright.